Hi, class. So today we're going to be studying a little bit of chemistry, kind of like an introduction, because we're going to need it to understand our topic of how to date things. And we're going to start with some absolute dating and some tools we might use for that. So chemistry can be intimidating to some, but it's really a very fun subject to celebrate. I have on my chemistry earrings. Over here we have this is a caffeine molecule, and on this ear we have a caffeine cup. And I have on my chemistry shirt. It says, I wear this shirt periodically. Get it? I wear this shirt periodically. It's a periodic table. So you should never have to explain your own jokes. I know. So chemistry, we're going to do some basics. The idea of chemistry is simply that there are things in our world called atoms that combine and form into new compounds, and that's the stuff of our world. It's a fascinating field. So here I have a picture of a diamond. A diamond is made of nothing but carbon atoms. The symbol for carbon is C. At the same time, over here, I have a pencil lead, either mechanical or regular pencil. Pencil lead is made of nothing but carbon. Graphite. Graphite and diamonds are made of the same stuff. So is a lump of coal. Their chemical formula is simply C, yet look how different they are. Diamonds are one of the hardest substances on Earth, and graphite, you know how soft it is. You barely have to touch it to your paper, and some of it comes off on your paper. So why is that? Well, chemistry helps answer those kind of questions. The diamond structure, it's how the carbon atoms are put together. They're formed in extremely strong shapes. So remember our bridges where we talked about strong shapes, and do you see how these are formed with a bunch of pyramids? And it's hard to get a sense of it here, but pyramid upon pyramid upon pyramid creates an incredibly strong shape. And here it is shown in chemical formula. But graphite is made in layers or sheets. And so there's one sheet of graphite on top of another on top of another. These are the carbon atoms being connected in these rings. And what happens when you write is just it takes a very small amount of pressure, and one tiny, tiny layer of graphite comes off on your paper. And so it's one of the softest substance. So same chemical formula, but how it puts together. That's the stuff of chemistry. So chemistry is all about atoms. Atoms are the smallest particles of matter. Matter is anything that takes up space and has some mass to it. So this is the picture. We'll see a lot of atoms, but this is just a model. It's a drawn model, although the parts of the atoms are correct. Subatomic parts of proton, neutrons, and electrons, and a nucleus. This is actually a real um, image scientists have gotten of atoms, but notice it's just the atoms themselves in a type of metal. And we were talking about metals earlier. You can see the irregularity right here where the pattern is changed. And so we don't really see atoms like this. This is the closest we've seen, and that's pretty incredible. So elements are atoms of all one type. So right here we have sulfur. This would mean this chunk here, this yellow chunk, is got nothing but sulfur atoms in it. Now, sulfur is contained in many things. Sulfur is what you smell if there's a rotten egg. It gives off sulfur gas. So sulfur can be in many things. We don't normally see sulfur sitting around all by itself. So most of these elements do not exist just by themselves. They combine with other elements. Here is the periodic table of elements. So everything on this table is what makes up the world around us. And like I said, you're not really going to see them by themselves. Most of these things exist with other things. Now, some of them you will recognize. Here's nickel. We know what nickel looks like. It's a metal. Copper is a metal. So a pure piece of copper is made of nothing but copper. It is an element. But we'll see that most things consist of multiple elements put together. So here's a classic chemistry example. Sodium, Na, is a soft silvery metal. So this is what sodium would look like, and or does look like. And if you found a piece of sodium and threw it in water, it would explode. But you're not going to find any sodium laying around. It simply does not exist like this out in the natural world because it's so unstable, it wants to combine. Here's chlorine. chlorine, symbol is Cl. Chlorine is a green poisonous gas that has been used in wartime to kill people. If you breathed it, you would die. And you don't have to worry about, oh, there's some chlorine over there. I better not walk over there. It's just not going to be found in our natural world on its own. But when you put these two things together, sodium plus chlorine, you get sodium chloride, which is nothing more than table salt. And we eat table salt every single day. So again, the stuff of chemistry. I love it. You take a metal that's going to explode in water. You take a poisonous gas, you put them together, and you get something you put on your French fries. And it doesn't hurt you at all because it has completely changed its properties, and it is now a brand new substance or compound. So that's what chemistry is. And so in order to understand absolute dating, we are going to have to learn a little bit about the atom. So, how are atoms made? They are made of various parts. They have a nucleus, which is the central part of the atom, and it contains protons, which are positive subatomic particles. What does subatomic mean? It means it's smaller than the atom itself. So, subatomic, smaller than an atom, a piece of the atom. Neutrons are neutral subatomic particles that you find in the nucleus. And then you have around the nucleus, the center part, you have this like cloud of electrons. We sometimes call them shells or energy levels. And they contain all the electrons, which are negative subatomic particles. So we didn't get to do a lot with this, but we did a little of this before school was out, that everything has charges and most things want to be neutral. But positive charge, if we were talking about batteries, and batteries have a positive and a negative into them. So these protons, neutrons, and electrons have different charges. So here's a simplified view of the atom. And again, this is not what we see when we look through some sort of microscope. This is what's been figured out by the way the subatomic particles act. So we have a nucleus in the middle, and then we have these different shells of electrons around the outside of the nucleus. And here we have the charges. So if chemistry is new to you, you can go back and pause the film and look at these diagrams to help you out, maybe even take notes. If this is a review, that's great. Maybe you don't need to take any notes. So here's our periodic table again, just showing you each of those are different atoms. And I want to show you what the numbers mean. So this atomic number is at the top. See how they all have an atomic number? What this means is this atom has 3 protons. This atom has 4 protons. This atom has 5 protons. So that's what the atomic number stands for. The symbol is always a capital letter, and if it happens to be 2, like aluminum is 2, it's going to be a capital A and a small l. So you always just do the first letter capital and the second letter a small letter. So notice they all are 1 to 2 letters for their symbols. Atomic weight is right down here at the bottom. So chromium has a weight of 52. Iron here, Fe, stands for iron. Notice they don't always match, and we won't get into that now. But iron has a weight of 55.85. When we get into how we date really old things like fossils, this atomic weight is going to be part of what we need to understand. So the atomic weight of hydrogen is 1.0080. And we'll be finding out why they aren't nice and even numbers. And then underneath you have the name of the element. So the colors help you see what kind of families they belong in. And basically, if they belong in the same family, they share some characteristics with other atoms in that family. So the atomic number of protons, atomic mass number is the number of protons and neutrons. So it tells you how much the atom weighs. And if the atom is neutral, then the number of electrons is equal to the number of protons. So let me say that again. If it is neutral, which means it has no charge, then the number of electrons is equal to the number of protons. So if we look over here, This one has lithium has 6.939 as an atomic mass. So that means, or atomic weight, so that means that the number of protons and neutrons together is equal to this number. Okay, and then the top number of protons. All right, so that's our short little chemistry introduction. The second part of the lesson is a simulation that I'd like you to play around with. So I will show you that in part 2. Thank you.